Best companies are always operating on the edge of chaos. At that time, everyone thought it's going to be a very, very bad decision, including my board and investors and a lot of people in the team are like, why are we doing this? Because
The internet we use today wasn't built for the world we're stepping into. A world that demands more speed, more power, and also more control from us humans than ever before. Today's guest on Founders and Builders is Mahdi Yahya, and Mahdi's building the invisible layer between AI and the physical world. This is not new to Mahdi. He's been building data centers for over 20 years, and he's now raised around $150 million for Ori, the operating system for AI factories. We cover topics like how is AI created, and why are we building these massive GPU farms on land and underwater. One of my favorite parts of this episode is when Mahdi says,
once you raise money, you have to spend it on growth and do things and move quickly and
clock's ticking.
yeah, exactly. And I fell in that trap at the beginning. But then you realize that
I'm Joe, this is Founders and Builders. Now let's get into it. So for everyday people, let's say we use apps, we use websites, we stream videos, but we don't necessarily understand what's going on behind the scenes. What is changing under the surface of the internet right now?
I think before we get into that, it's good to look at the history of the internet infrastructure, especially in the last, I would say, 15 to 20 years, like from the early 2000s, and how that evolved to where we are today. The internet that we've had, I would say, and the internet that we're in today, in my view, is a content internet. And what I mean by that is that the use case of content, like content consumption, content generation, content streaming, content in all its forms at the moment that we use. I mean, this podcast is a content, right? Piece of content that we're streaming and we're doing things across the internet. The rise of that content internet drove basically how we build the infrastructure for the internet we have today. And that, I would say, fueled the rise of the cloud, hyperscale cloud, vast amounts of computer data centers. That drove the building of what we call content delivery networks and so on. And that's the majority of the internet that we have today and the majority of how the internet operates today. The next, I would say, use case that is now driving the transformation of the internet infrastructure as we know it is obviously AI. We know that AI is becoming and it's going to become part of every piece of software that we use, every piece of application. Some of it we know how, some of it we have no idea how it's going to do that, transform, how we use infrastructure, how we use applications. And AI has a different way of interacting with hardware, interacting with infrastructure. And basically the simplest way to explain it is that we're effectively now building supercomputing infrastructure at an unprecedented rate. Not just so, so many companies around the world today, and we're putting those in what we call the cloud today. And that is basically transforming the whole backbone of the internet to something completely different. Because once you start building a series of supercomputers, to give you an example, like a supercomputer used to take 1 or 2 years to build, and the whole country talks about it, and the government goes up and makes an announcement that we built this, supercomputer at that university, right, or at that research center, and so on. Today, we're building the same scale of these supercomputers that used to be built in universities and research centers, but 100 times more every month, even sometimes, if you look at globally. So the scale of building this supercomputer, high-performance computing infrastructure is something we haven't seen before. And that's driving transformation across multiple industries as well. So across the data center industry, obviously these machines consume a lot of power. So the energy sector is completely changing now to keep up with that. But on the other end as well, at the end of the day, we're building all this infrastructure for people to interact with AI. So the pipes of the internet, the networks that move traffic and data and everything else from users, or whenever you interact with something, it's sending packets through pipes, basically, or cables. The way we build that is also changing today to keep up with this demand and to basically support the current use case and the growth of that use case. So there's a whole fundamental transformation, I would say, on how we're building internet infrastructure. And the internet we know today, from a technical infrastructure standpoint, is going to be completely different, like 5 years from now, I would say.
It's interesting because it kind of follows the early days of the internet, right? It was used for primarily research purposes, ARPANET before it was called the internet. And then, we always think about Moore's law maybe in terms of consumer devices that are the chips in our
Mhm.
smaller again in our phones are getting smaller and faster. But what does that? Do you have some like figures around the scale of dispersion of the size of these supercomputers that are getting built?
Like, what do you mean by scale? You mean like from a computing power or cost?
I'm probably thinking about like the size of the data centers that need to be built to serve the next gen of the internet.
Oh, I mean, I've been in data centers for, what, 15 years, a bit more even. The biggest deployment we used to do in the past was about 100 kilowatts, 150 kilowatts. 300 kilowatts was huge. Like the whole building of the data center used to have maybe 1 or 2 megawatts, and that's used to be considered a big chunk of power, that you can use. Today, the smallest deployment we do as a company, a single company, is around 1 megawatts, in a data center as a tenant,
Mm.
right? So the scale of like power needed for this infrastructure is 100, even more, like I would say 100 to 500 times more than what it used to be and what it needs to be moving forward as well. I mean, we're talking about gigawatts and gigawatts of power now that we need to put in. And you've seen there's a lot of announcements and investments. Companies are putting in data centers and power that are in the gigawatts, right? To tell you where it's going and how much, I have no idea, to be honest. But I do know that the scale is unprecedented in terms of infrastructure today.
But your background wasn't always in data centers and building early stage tech companies. You actually started off a life in theater.
It was the other way around, actually. So I started my first company when I was 20 years old in data center networking. And then at 23, and I didn't go to university. I went to university for like 6 months, and then I just started a company. And then I wanted to go back to uni around 23. So I've had a passion for, the performance arts, I would say, since I was a kid. I'm not an academic person per se. Like academia doesn't really appeal to me. Like studying something in an academic sense is not appealing to me. Studying business or studying technology or compute, because you can learn that. I'm more of an execution doer type of person, So, and there's nothing wrong in academia. I'm not saying that, but it's just me as personality. Academia didn't appeal to me at all. So I decided to go and study theater, and I was in London. It's the theater capital of the world, right? So yeah, I went to university here and I did drama and theater while I was still running my first company as well. I say I'm not academic. Theater is very academic in a sense because you have to do a lot of reading, but at the same time, it's a great way to learn how to tell stories. It's a great way to learn about human characters and interactions. And it's a great way to learn about the world in general, because playwrights and theater and even film, it just takes, snippets from the world, takes snippets from humanity, and they put them in a package for you to understand and study, I would say. And I think that was the appeal for me back then. And I did that here in London for 3 years, and it was a great experience, I would say.
And the ambition, we've talked about this before, but maybe long term you'll be working on creating your own movies.
Yeah, I mean, this has always been a passion and a plan of mine. I say, if at one point later in life I stop doing what I'm doing today and I have more time, I'm gonna make films. And I think the best filmmakers are the ones who make films later in life, because you need to have gone through things and you need to have a better understanding of humanity and humans. And the only way you have that understanding is by experiencing it, I think. And I'm talking about proper storyteller filmmakers. I'm not talking about commercial type of filmmaking in that sense, right?
Who comes to mind? Who's inspired you?
In my teenage years, I was really into Russian cinema at one point, and like Tarkovsky. He's a bit more mainstream now. Everyone talks about him, but back then, like, it was something that nobody, and you couldn't stream things back then, right? So I had to go and buy tapes or DVDs later as well to watch these films. Bergman is another filmmaker that I like a lot as well. I mean, the list goes on. Like Wim Wenders, From the more current ones, I think, I mean, I'm a big fan of like Interstellar as a film. I mean, I love science fiction in general as well, so it's a well-made film. I'm trying to find references that are closer to our time as well today, because most of these were 70s, 80s type of films.
Yeah.
The French had this movement called the Cahiers du Cinéma, like Truffaut, Jean-Luc Godard, and all these filmmakers. And not many people know that Hollywood's structure was based on these guys.
In what sense?
Like Spielberg actually spent a lot of time with Truffaut as well, and because they built an industry in France, filmmaking industry, and that's called the Cahiers du Cinéma. And these filmmakers came together and they started basically building structures around how to tell stories through film, and each one of them had their own style of telling stories and so on. So Hollywood, like the early Hollywood guys, took that structure as well, and they basically were inspired by it to build basically what's Hollywood today as well. And there's a book about that actually called Cahiers du Cinéma that you can read.
Nice. Okay, cool.
About the influence of these filmmakers on Hollywood.
And what led you, after working in a data center, then pursuing your passion of theater and, let's say, the arts? What led you to then founding Ori?
I did my first company for about 7 years, and basically I've learned everything about data centers, the backstage of the internet, global infrastructure, and everything else through that company. I mean, I didn't know anything before that. Again, that story around, there's a use case usually that drives how we build infrastructure. And for me, it was, what's the next use case that will drive the growth of infrastructure? And I founded Ori about 6 years ago now. To tell you that I knew that AI is going to be what it is today, I'd be lying. No, like, I didn't know. The company was started on a thesis that there's going to be a time, like a point in time in the future, that a new use case is going to come in and it's going to govern how we build infrastructure. And there's going to be a business in the platform that will govern the relationship between that use case applications and this new infrastructure. And the company was formed to build that platform, that little middle layer that will govern that relationship. That was the early days. We didn't know how we're going to do this, what we're going to do. And we raised our first round based on that, basically like a month later. We started basically experimenting with multiple use cases. So there was, at that time, like edge computing was becoming things, saying, okay, well, workloads are going to move from the cloud to the edges of the network, closer to where the users are.
When you say to the edges of the network, for people that are not so familiar, you mean like close to the device itself?
Yeah, close to the device. I mean, you have to think about like the device today is here. When you do anything on your device, I don't know, like something on Instagram, as simple as that, that's sending a packet from your phone to the nearest base station of the mobile network that is giving you a 5G connection. And then from there, that's going through multiple hops through the pipes of the internet to get to the Instagram server somewhere. And that could be in the US, it could be in Europe, doesn't matter, but it could be somewhere. And that Instagram server, processes that request and sends it back to your device to say, yep, you've given a like, right? So, and this is simple. I mean, imagine like...
I mean, we've normalized this, but that even happens is...
It's crazy.
kind of black magic.
I love it. I love it. And like, imagine like billions and billions of these requests going through the pipes of the internet, not on daily basis, probably every hour now, right?
Literally flying through the air.
Exactly, flying through the air and going through physical cables. There's physical cables in the ocean connecting the continents. Like these are called submarine cables, if you're familiar with that. I mean, it's fascinating. There's maps online that you can see where submarine cables are. So it's not the only piece that goes through the air is from your device to the network base station, but everything else goes through cables. Like the whole internet between the American continent and the European continent is through cables passing through the ocean. It's fascinating stuff. So going back to that point, basically that server, that the whole concept of edge computing was that that server that is somewhere far away in a data center, maybe you can bring that closer to where the user are. So you reduce the amount of hops that this packet needs to go through these these pipes, basically. So it reduces the cost on the network, because then the more you send traffic, the bigger the pipe needs to be, the higher the cost. And it also makes it faster, basically. But I don't think that took off the way we thought it's going to do, because I don't think there was a clear or a pressing problem per se.
Are you describing content delivery networks?
So content delivery network does exactly that, but it mainly focuses on caching content closer to the users. So that took off, and that's a huge, huge industry, right? But what edge computing was trying to do is to do same thing, but bring all of the computers, so not just caching content and processing content, but actually do all of your computing and processing at the edge of the network. And there was no need for that, I would say. Back then at Ori, we built our platform based on delivering applications and deploying applications with like compute and the networking and the security and everything else on these edge computing locations, basically. But that didn't take off. And at the same time, AI was another type of workload that people were saying it's going to work at the edge. So we were starting to work with machine learning applications and understand how it works, the type of compute machine learning applications needs to run on, and understanding the whole concept of training and inferencing models and deploying models and running models and so on. Over time, it became apparent that AI is here to stay, and it's going to become a very large use case. And that's when we thought, okay, this is the use case that is going to change how the internet is built. And we need to be a part of that. And we focused all our efforts and our development and engineering and R&D efforts towards building something that will service this use case. And that's this was 3 years ago, a bit more now. And yeah, that's been our focus, and we've been successful at it so far.
Super quick one from me. As you know, every week we ask our listeners what is one tool that they couldn't live without. And this week, everybody's talking about Claude, Anthropic's leading LLM. If you haven't used Claude, think of it like ChatGPT's cousin, except instead of telling you what it thinks you want to hear, it'll tell you what you really need to hear. And I use Claude as basically like a personal therapist literally every week. I know teams and founders using it for research, customer service, and Claude is only getting smarter. So if you'd like to find out more about how you can start using Claude, check out the link in the description below. And for now, let's get back into the episode. So for those that don't know about the GPU cloud space, I'd love if you could kind of humor me for the next 10-15 minutes. Let's build it all the way up from the base principles. So let's start with the GPU. Why is a GPU important versus any other type of chip?
To simplify it, right, AI needs a lot of computing power. People talk about GPUs, which are graphical processing units. They were built originally for graphics and gaming and 3D animation and everything else, because they had capability to parallel processing. Without being too technical and just keep it simple, you can process multiple things at the same time. You can process millions of things potentially at the same time versus serial processing. That was made for graphics, because real-time graphics and gamings and so on required a lot of computing power, required parallel processing.
Multi-threading.
Yeah, multi-threading. AI requires the same, right? It requires parallel processing as much as you can and a lot of computing power. So it just was natural for GPUs to be, to fit the AI computing needs at that time. I don't even know if we should call them GPUs anymore, because they're not necessarily graphical processing units at this stage. But I think that the brand is there in GPUs. And, there's other players who built accelerators today, as you call them, like LPUs and DPUs and everything else. So it's more about accelerated computing through this new, computing chips and the ability to do parallel processing. And parallel processing is in GPUs, but there's other chips that do different things now and so on. There's a lot of research and development happening in that space. So GPU were the best available computing resource for AI, and therefore they became associated with AI computing. Now, as you know, there are two things you do with AI today. You train a model, right? Or what you call inference, which is you deploy the model when you put it in an application. So to give an example, everyone knows ChatGPT is an application built on top of a model trained, which is called GPT, right? So when you take GPT and you put it in ChatGPT and people start interacting with it, every time you ask a question with ChatGPT, again, sending a packet through the pipes of the internet, processing that and giving you back an answer, that's inferencing more. So that's deploying and putting it into action, putting it in the hands of users, basically. And this requires a lot of compute power, both. Training requires huge supercomputers. The bigger it is, the quicker you can train, the better the model. As you know, there's this race between all of the different AI companies. I mean, XAI keeps making these announcements and bragging about how big their supercomputer is. This is all for training a model, right? And this is an incredible amount of compute, an incredible amount of power being used in the background. Now, not everyone has the means that XAI has or OpenAI has to go and buy a very large supercomputer and deploy it in data centers. But there's a lot of people who want this compute. There's a lot of startups, there's a lot of enterprise, a lot of companies that require this GPU compute. And that's where the concept of GPU cloud started, because a cloud is an OpEx model where you don't require huge amounts of investment in CapEx to buy this infrastructure. And you can just rent it by the hour, by every month, for a year or whatever, and you do the job that you need to do on this infrastructure. So GPU clouds are basically the same commercial model and the same value that the cloud brought to the world in terms of turning a CapEx model to an OpEx model, but specifically catering the AI industry, people who want massive amounts of compute, but don't have to pay for the whole thing upfront in CapEx, basically.
And just winding back to the importance of the GPU, I think one thing you said earlier I loved, which was that the use case drove the infrastructure. And in the case of the GPU, at least from what I understand, but tell me if you think I'm missing something, is, the reason that this parallelization and the reason that a GPU versus a CPU is more powerful, more useful, is because we found that based on this paper, attention is all you need. The more data we throw at these models, the better that they perform.
Yeah, and the more data you throw at them, and the more processing you can do of that data, the quicker processing you do of that data, the quicker your model evolves. And I think that's why these models and applications are evolving on daily basis now. Like, you can't keep up sometimes in terms of the developments. We were talking earlier, I tried a music generation app 3 months ago, and I was telling it's not good. Now you're telling me it's actually good.
Yeah, you have to check it out, guys.
I will, because 3 months ago, maybe there was none of the developments that happened today, right? So yeah, I mean, and this computing power that we're constantly building at the moment is basically contributing heavily to the development of AI and to make it smarter and better.
So people need access to GPUs. They maybe don't have hundreds of millions of dollars to build their own supercomputer. They maybe can't access it through their national government. So introducing GPU clouds, how, if I'm thinking about building an AI system as a company, what are the questions that I need to ask to figure out what my different options are?
That's the value proposition of GPU clouds, what you mentioned. That's why GPU clouds existed, right? The world is becoming more sophisticated at the moment in terms of what's beyond GPU clouds and what do I need beyond the GPU, right? So if you're an early adopter type of companies, like a lot of the startups are quite tech savvy in terms of infrastructure, especially the early AI companies, they were happy with just having a bunch of GPUs. That's all they needed. I'll rent a cluster of GPUs and then I'll do the rest myself. But the world is starting to change now, especially as the adoption rate is starting to grow in the non-AI native companies. I'm talking about enterprises, even other startups, right? Whether you're from legal, manufacturing, financial services, and so on.
Let's face it, the vast majority of companies are just not AI native.
Exactly. I personally believe that's where the real AI market is going to happen, right? For a lot of these companies, just getting a GPU in the cloud is not enough, I would say. And it's not enough anymore because most of them don't know what to do with it on its own, right? It requires special in-house technical skills and teams and so on. And even like the AI native startups now, they're starting to demand more from infrastructure. They have an experience in the traditional cloud where everything is as a service, everything is abstracted away, and I have to do the least amount of possible on the infrastructure myself, and I just focus on building my application. So for companies today and anyone who's looking at GPU infrastructure, you really need to focus on the layers above GPU, just beyond the GPU, I would say, because the more abstraction, the more services, the more you have hosted services on top of this infrastructure, the more it makes your life easier and focusing on the application or the service you're building. I mean, if you're building a video generation app, you shouldn't be worrying about the infra. You don't want to be worrying about the infrastructure. You don't want to have a team that is sole purpose, basically managing and building infrastructure platforms, because it's not just a matter of your application and the GPU. There's a whole gap in the middle of platform services that need to be there to support your application operations.
Things that a software founder wouldn't or shouldn't have to think about.
Exactly, yeah.
How do I water cool the GPUs? How do I create an abstraction layer so that my developers don't have to write a Slurm job every time they want to deploy to a GPU?
Exactly, and you shouldn't even have to manage things like Kubernetes and things like this. Even now, like managed Kubernetes has a specific form that grew over the years. For AI, it's even different, I would say. And we have our own way of actually managing Kubernetes specifically for machine learning engineers and data scientists that have never touched Kubernetes before in their life. So taking the classic cloud models from the incumbents and trying to apply that here, I apply it to high performance computing and accelerated computing in a cloud. I don't think it's the right approach. And there's a lot of people think you can just port that in and put it there. I think even here, we have to rethink the cloud model even as well. So how does the cloud deliver basically this compute and these services to the end customer? And that's how we always thought about it, basically. So it works to some extent, the cloud model today, because companies are used to that. But we don't think over time that's how compute is going to be served, I would say. And we have our own view of the world of how compute is going to develop and how people are going to consume it. And again, we always think of ourselves not as a GPU cloud, but as a compute platform layer that actually governs the relationship between the new applications and whatever compute comes later, today and later, basically.
Earlier, you mentioned when you started, Ori, 6 years ago, did you say? That the vision was to build this kind of this gap, this connective tissue between whatever the infrastructure is and the end business use case, knowing that there will be a change in the future. You started off, from what I understand, as a pure software company, but then you started to move into a fully integrated system. Can you walk us through the key learnings in that journey?
Ori comes from biology, the name as well, which is Ori DNA, which is the origin of replication of DNA. Basically, that's I was Googling and I found the name there. I said, that's because we always thought of our platform as this connective tissue. It's funny you say that, but we always thought about it as this connective tissue, like a biological connective tissue between infrastructure and applications and so on. So yeah, absolutely. I mean, we started as a software company. We still are a software company. Software companies today in infrastructure have a different form, right? You might have data centers, you might have infrastructure, but your platform, the connective tissue, can scale basically across different types of infrastructure as well. And the value that you give to the customers is always the same through that platform, basically. And when we started, we thought we were going to just sell software. But 6 years ago, nobody really, AI wasn't as present as it is today, right? So selling software for AI clusters was not a thing, and nobody had them, and nobody was thinking about it, and nobody thought there's going to be value for that. And as the GPU market started to grow, we found ourselves in this market that is growing with a unique piece of software technology, we believed, and we decided to use that ourselves to build, a cloud-like experience for our customers. And that's what got us into starting to going downstream. And I think we were a bit lucky as well ourselves, because I have a background in data centers, so I understood what it takes and what it needs to basically build a data center infrastructure. Our CTO had a lot of background in infrastructure and data centers as well. And with the software platform, we thought we can build a new value proposition to the world, and that's what we did. But again, the market is evolving rapidly at the moment. So we have a lot of people now coming to us for our software, basically. And because we've built our platform from the ground up as a software platform as well. We're now thinking about how this world is going to evolve. Is the cloud that classic incumbent monolithic approach to everything, where they built the data center, the infrastructure, and the software and the services and everything else, and you take all of that as one big slice of service?
For which they can charge a high margin,
Exactly.
hyperscalers.
Or is the cloud, as we know, it's going to change, and it's going to be more of a modular approach, because there's companies that are buying their own GPUs today, whether for financial reasons, because sometimes a CapEx for certain companies is better than OpEx, whether it's for compliance even. So we have a lot of enterprise and government conversations in Europe, specifically around the compliance of the data, security of the data, because AI is all about data, right? I'm sure you've seen the whole sovereign initiatives talking about sovereign AI, sovereign infrastructure, sovereign data. I mean, that touches a lot on the infrastructure. Where is the infrastructure? Who owns it? And who controls that infrastructure as well? The movement in terms of how infrastructure, physical infrastructure, is being deployed and consumed would change how we think about the cloud today. So these customers are potentially buying infrastructure, but they still want the cloud experience on top of it. They want the abstraction and the services that cloud gives them on top of that. And that's where we're starting to think of a concept of the modular cloud in terms of how the cloud is going to evolve. And does a cloud always have to give you this whole monolithic service, or the cloud can give you portions of what it has, depending on each use case and depending on your needs and compliance needs and security needs and everything else, basically. And that's where we play in this space and what we're thinking. That's why I don't like when people call us a GPU cloud. I mean, GPUs is part of our offering, it's part of our service, but we're not at the surface a traditional GPU cloud per se.
And if we step outside of just GPUs, let's talk about like the market and what the world looks like at the minute. So a few things when I was doing my research, the latest OpenAI model, when you talk about training it in these huge clusters of compute, took over 3 months and over $100 million. NVIDIA owns over 90% of the GPU chip market. It kind of feels like NVIDIA is the only option now if you want to build a software stack on top of the chips.
I mean, NVIDIA is the most successful option, and they're the most in demand because obviously they have the most powerful chips, and they have a great developer community around their infrastructure and their drivers and CUDA and everything else, which gives them I don't know how to quantify their head start in the market, I would say. And they're the most performant and stable option, and not the cheapest for sure, but they're the best option at the moment, and they're doing a fantastic job at basically keeping up with the market demand and producing new infrastructure, new chips every year, even less now as well. So as a platform for AI compute, obviously our focus has always been primarily on NVIDIA because that's where the demand is and that's where the advancements are. But we also play nicely with other chip manufacturers today who are not as advanced as NVIDIA. But I think from a platform perspective and a platform provider to our customers' perspective, it's our duty to our customers to basically try different options and be able to have a diversification of silicon, of accelerators for whatever use case comes later, basically. And if NVIDIA stays the only option and, the leader in the space, which I don't see a world where they're not anytime soon, to be honest, then we have a great partnership with NVIDIA and we work closely with them. But if other basically players and providers come into play for maybe very niche specific use cases, we need to be there and prepared for that as well so that we can support our customers with any use case that might come in later. And there's this unknown in the market because nobody knows where it's going. I feel it's our responsibility as infrastructure providers to be prepared for the unknown and whatever is going to happen later.
And there's another point now I wanted to go back to, which is where is the intelligence taking place at the minute? From what I can see, at least, once you've trained these huge models and they live, in some, let's say, some centralized server within the US, and we're all pinging ChatGPT our requests, Where is the intelligence taking place today, and how will that change over time?
Intelligence, you mean, in the model itself?
Yeah,
Or,
the actual kind of compute, the reasoning.
I mean, most of it is in the US. It depends on what type of models you're using, obviously, and what type of applications you're using. Majority is in very large US data centers, uh, just by nature of most of the large, AI, like foundational model builders are US based. There's a whole deployments happening today in Europe for infrastructure, in APAC, in the Middle East. The compute is going to be global. So it is a bit global at the moment, but majority in the US. But there's a lot of deployments happening today in Europe specifically, for example, and so on. So eventually, wherever you are in the world, you'll be served from the closest compute data center location that you have to you, I would say. And the intelligence happens across all of it. Obviously, I mean, you're using the model, and the model data and model weights and everything else could be replicated everywhere and deployed everywhere.
Hmm. I've seen some companies that are talking about privacy first and maintaining like open weight, open data models, maintaining the control and keeping the compute on device. What's the significance of that?
Privacy in AI specifically is multiple things, I would say. So the one we deal with a lot today is in the enterprise. There is I would say in enterprise specifically, there's a misconception that the data you have is your defensible moat. So you need to protect that. That basically drove enterprises to think about where they're hosting the data and how they're protecting it and ring fencing it and everything else. The privacy aspect, basically, in AI specifically, is not necessarily about the historical data that you own. It's more of the data that is being generated as you interact with AI. That's one you can protect. And there could be different reasons, not necessarily an intellectual property reason, but more of a security aspect, I would say. So let's say you're a large organization like Fortune 500, and you implemented a whole AI strategy across your whole organization, and all of your employees and customers and everyone is interacting with the applications and the agents and everything else that you've built on top of these models. That's generating a lot of interaction data on a daily basis. It's generating data about probably how some of your employees think, about your sales strategies, about your business strategies, all of that, because these interactions are being basically fed into the AI. And I think that's something needs to be protected. So the concept of bringing it to device or bringing it on-prem is because of that, I would say, because if you just use a generic model in the cloud, you have no control where these interactions and data are going today. Even if you try and ring fence it in the cloud and so on, there's still, AI is still a black box for a lot of people, even from a security perspective. That's kind of my view where this is coming from. It's about all the interactions myself and my employees and my customers are having with these AI models. I need to protect that. I need to make sure it's basically ring fenced somehow.
Mhm.
And naturally, you start with the infrastructure and you start thinking about device or on-prem or something like that.
Mhm. But the intuition of, some people talk about RLHF, like capturing the proprietary data that makes their experience of using their product the moat versus 5 other products in the same category. That seems to make sense, right? It seems to make sense that they would like to protect that.
Yeah, I mean the interaction data is what I was talking about is also within that as well, right? I mean, workflows is another aspect, right? Like you can have the same model with the same data with two different companies, but how you implement that and the workflows you do through that could be completely different things, and they can give you different results as well. So the data around how you're basically building these workflows and how you're interacting with it and how you're improving the processes and everything else, that's something can give you a defensible mode to some extent, yes. But again, like, we don't know yet. Like, it's there's a lot of speculation. There's so many R&D, there's so many trials and so on, but we have no idea how this is gonna play out.
So I'd love to step maybe outside of the GPU market right now and into your experience of building Ori over the last 6 years. So question is, What are the 10% of decisions that you've made that drove 90% of the value or success that you feel you've had so far?
3 years ago, we made the decision to acquire a small company. It was a 3-people company. And I think that drove a lot of value for our business, and it kind of helped us to be where we are today. I mean, the team from the founding team from the company are an integral part of Ori today, and they're part of leadership, and they're some of the smartest people I know. Um, and that was a very small decision that at that time, everyone thought it's going to be a very, very bad decision, including my board and investors and a lot of people in the team are like, why are we doing this?
What gave you the conviction?
It's very hard to hire really good people. And hiring people sometimes could be done in so many different means, I would say. And not just hire good people, but also get along with good people. I met these guys and we had few conversations, and sometimes there's a gut feeling and there's an instinct that you follow, and I follow that a lot in terms of decisions I make. And it was at a time where we were forming what we're doing. It was a transition time, is AI is going to be a thing? Is it not? Is edge computing going to be a thing? And so on. And then I had a really intelligent, pleasant conversation with these guys. And I said, hey, why don't you come and join us? And they were still starting, so the timing was right as well. And we kind of built a connection and a bond, and basically they came in and we acquired their startup. And I think that drove big portion of value to what we're doing today, I would say. Otherwise, I wouldn't have been able to hire these individuals in a traditional sense, I would say. And I don't know where we would be today.
You don't hear of it often that you would kind of, as a small company yourself, acquire another startup.
Yeah, I mean, science doesn't pay anything into this. It's the same concept, right? We were small, they were small, and I mean, we were slightly bigger than them, so it just made sense.
What other decisions come to mind when you think about, early bets that you made maybe that had an outsized impact on the company?
Whenever I think about bets and early bets, it's always on people. I'm not an engineer by training or by studying or anything like that. So I understand technology very well. If I look at code, I understand. If I look at technical concepts, I understand what they are. But I don't build technologies myself. I never had. So it puts me in a position where I'm basically reliant on really good people and creating the right environment for them to build things and to achieve things and so on. So that's why whenever I think about early decisions and early bets and so on, it's always about people, because if you look back now and connect the dots, nothing we have today, I would have be able to do it without the people that have been with us around the journey. And what I mean decisions on people is decisions on keeping people within the business, but also decisions on basically removing people from the business as well. And there was a lot of that also at times, because my management strategy and my leadership strategy is always through people. So most of the decisions I always made, and the big ones that have an impact, are around helping somebody grow within the business and betting on them, or deciding to remove people in the business.
How do you know when you know?
It's black magic, man. I don't know. I mean, sometimes there's obvious signs that this is not working. Experience and knowledge, you realize very quickly that doesn't mean anything, right? Loyalty, dedication, the right attitude, the ability to basically be comfortable with chaos. Because, running a business is chaos. From the outside, everything looks, but there's always chaos. And, and the best companies, I don't know, like the Netflix CEO once talks about the edge of chaos. And I love that theory, Best companies are always operating on the edge of chaos as well. And that's not for everyone.
Yeah.
So people are comfortable with that and can adapt through that and can learn quickly. I mean, I love people that can learn quickly as well. You can see these signs and you can sense it sometimes in someone that they have that ability, and you just bet on them more and more and more and more. And eventually you end up with a group of people who share similar traits in learning, in ambition, in adaptability, not necessarily traits as in, people. Everyone is different, and we have so many arguments as a business, and that's important, I would say. Like, they're healthy arguments in terms of what's the best decision we have to make
Yeah,
for the
fostering that culture of disagreeability. Yeah.
Exactly. That allows you to start making better decisions as a team. And that basically makes you stronger and stronger and stronger as you grow, and you create a very solid base of individuals that you can rely on to build anything and to make the best decisions out there, basically.
Yeah, one of the books that I read by Ray Dalio, Principles, I don't know if you've come across it, he talks about this idea of everyone comes in, has a almost top trumps card of their area of competence, their area of genius, and how to make believability weighted decisions.
Yeah.
How is your approach to not just bringing the right people in, but managing a team towards a vision, towards a goal that may be moving goalposts? How has that developed?
If everyone agrees on everything, that means you're not doing the right things. That's how I always, that's been my learning, like, firsthand. So I always see my job as not telling people this is what we need to do, and then everyone agrees and goes and do it. And when people agree with me from the first time, I always get worried, to be honest, and I get a bit nervous. Like, why are they agreeing with me? Are they not, comfortable to say no?
Mahdi, we get it.
Right? So that, like, culture of disagreement you're talking about basically means that we're all sharing the same vision. But it has to be the right people, and it has to be people that you trust, that they know the vision, basically, that we're working towards. Because sometimes you might come up with something or a decision you make or something like this that maybe does not align with the vision, and then somebody would say no on the basis that they're protecting the vision. That makes sense. So that's how I usually know. It's basically when people are passionate about making the right decision for the company that aligns with where we want to go, that's when you know that you have the right people who share the same vision and are growing. Because the vision is a living creature, it changes and it grows, and you have the overall vision of where you want to be, and you always have an idea of that, and you kind of understand that once you are there, you would know, but you're never there, and you never know sometimes. But it's also that driving force for the team to push back on things and make the right decisions for us as a business, And when somebody is pushing for a decision for the business, you know that they're doing that selflessly. They're doing that for the best of the group, I would say. But it's very hard to get to that point, and it took us years to get to this point, I would say. And maybe we're not 100% there yet, even. Like, there's always ways to improve what we have. But we have a very solid group of people today that basically, again, like, I can rely on to build anything, and I can rely on them to basically protect the vision that we're all working towards.
Mm-hmm. You've said, and I'd love to get your thoughts on some maybe conventional startup wisdom now. You've said if you were to do it again, when we last spoke, you would take more time to think. People are in a rush for growth, for validation. What did you mean by that?
Look, I mean, most companies have no idea what they're doing when they start, right? Even if you have all the clarity in the world, reality will slap you in the face. At least that's been my experience. And I've been doing this since I was 20 years old till now. So rushing into things, especially after you raise money, there's this misconception I wouldn't say, maybe it's not a misconception, but at least for me, like, once you raise money, you have to spend it on growth and do things and move quickly and basically
the clock's ticking.
Yeah, exactly. And there's this concept of 18 months runway and all of that. I don't even know where that came from, but there's all these different concepts in startups and companies, and there's books about it and podcasts and blogs and everything else, and people read that and consume that, and you realize that's the only way I can succeed. And I fell in that trap at the beginning, but then you realize that it's okay to take your time sometimes. Like, some people will be successful very quickly, and some people won't. And taking your time and thinking is very underrated. Like, it's actually work. Thinking is work. Like, you don't necessarily need to be actually physically doing something all the time, Sitting down, thinking, analyzing, processing is real work, I would say. And I still do a lot of that today as well. I dedicate time to just think about things. And it's very, very important at the beginning to actually spend time on thinking and taking your time on making decisions, I would say. That in the moment, sometimes they feel like the right decisions and they just go in and just spend money on it and hire people and do all of that. And they realize that you become very heavy and bulky over time, and you can't really change when you realize that the majority of these decisions are wrong. And you will make a lot of wrong decisions at the beginning, and that's okay.
And this weight in the team over hiring, over planning, maybe processizing things that maybe don't need to be fixed yet, it erodes your only advantage of a startup, with your ability to change direction.
Yeah, I think so. I mean, I mean, early stage companies, and we fell trapped to that. Like, say, oh, I need to hire a head of people, and I need to hire a whole HR team, and I need to, all these different things that are extremely important in an
we're a company
organization.
now.
Exactly. So you have this idea of what a company shape needs to be, and then you go and apply that, and you raise money, and then you have the money to do that, right? But then you realize that you're not a company yet. You're not a business yet, even. Maybe you're a group of really smart people trying to do things and trying to achieve a certain outcome somehow, and you don't know what that outcome yet is yet sometimes, especially in what they used to call deep tech. I mean, our space used to be called deep tech in the old days, where you're building a technology in search for a solution, a use case. Maybe in other businesses and other areas, this doesn't apply, right? You have a problem out there where you're basically building I don't know, a SaaS product for that, and the customers are there and everything else. But in our space, deep tech, as they used to call it, you start with the technology, and that's a very, very hard thing to do. And most of the time it fails as well. So you're not a company until you actually have delivered value to a lot of customers and so on. And realizing that late was something happened to me as well. And you should keep it flexible and nimble at the beginning and take time to think. That's what I would do back then.
Mahdi, I've loved the conversation, loved the openness. Last question from me. If we fast forward, let's say 30, 40 years in the future, and you and I are sitting next to each other on the proverbial, let's say, deck chair, and we can look up and see the stars, and I turn to you and I say, Mahdi, what was it all for?
For fun. No, I mean, this is a lot of fun, man. Like, it's hard, but it's a lot of fun. And building something from scratch is extremely satisfying. Like I wish everyone can experience that. And as you know, I'm heavily involved in the art world and theater and film and all of that. And I see what I'm doing today as an artwork, as a piece of art. It's a different medium. It's a different audience, different structure. So I think for me, the real drive comes from the same drive when somebody paints a painting or creates a sculpture. What is that for? But you feel like you have to do it. And you feel like that will basically define you and fulfill you as a person, I would say. So I would say 30 years from now, I would hope to feel the same feeling as, I don't know, like Dali or Picasso or any of those artists have felt at the end of their careers when they basically created all this work to the world.
Or Gaudi in Barcelona, but instead of the amazing buildings that he built, just a huge GPU data center.
Yeah, why not? It's still a creation,
Thanks so much for coming on.
No problem. Thank you, Joe.